In this video, we're going to learn about the condition under which an object will sink or object will float. It would be in terms of buoyant force. So as and when we go across, you will understand the heading. You might be not understanding the heading as of now. So to begin with, we have two objects, object 1 and object 2. The mass of the object 1 is clearly 29 grams and the object 2 is 30 grams. So what is that we are doing is, we are going to sink them or drop them into water basically. Not sink them, drop them into water. Let's see what happens. So what happened? In first case, in case of object 1, number 1, it floated, is it not? In case of object number 2, what happened? It sank. Agree? So now the question is why and how? To answer that, we need to fill this table up, right? So the density of the fluid that we are using is 1 gram per centimeter cube. It's tap water. So we have seen that tap water weighs 1 gram for every centimeter cube. Now coming back to this. So let's see the buoyant force being applied on these two objects. How will we do that? Remember, we have to find the change in change in level of water. So here clearly this is at 200 centimeter cube and this has moved to this is, where is 200? I think this is, this is 200. 1, 2, right? Almost 4, is it not? So 1, 2, not 4, sorry, 3. 1, 2, 3. So this would be 230. So 230. Okay, guys. Over here, I did a mistake. It is a bit lesser than, half in between 190 and 200. I should have made it 200, but anyways, it doesn't matter. We still can measure it. This is 195. And here it is 200 exactly. Okay, guys. So let's fill the table up. Let's see what we'll understand. So very first thing is serial number 1. Mass of the first object is around 29 grams. Weight would be 290 by 1000 into 10 Newton, right? So 0, 0. And we have, let me actually do it a bit neater, 29 into 10 divided by 1000. Okay, guys. So 1010, this would be 0.29 Newton. Okay. Volume of the water displaced in the first one, it would be 200 to 230, that is 30 centimeter cube. The weight would be 30 into density of water, that is 1. In terms of kg is divided by 1000 into 10. 10101010. So this is approximately 0.3 Newton, right? Now in the second one, once we complete this table, we'll understand things, don't worry. So this is 195 to 200 and the weight is over here 30. So 30 grams, similar calculation, 0.30 Newton. Here it is 5 centimeter cube and the volume of or weight of the displaced water is 0.05 Newton. So all in all, what is happening? The case in which the object sank, right? What is happening? You guys have to match that. Try to make your own conclusion and then I'll conclude. So fill in this blank. So what is happening? The object will float if it's able to displace fluid whose weight is what? Yes, equal to that of the object's weight. Makes sense, is it not? See, the point here is this. Let me show you guys the mathematical aspect. See, for an object to stay in a place, what should happen? For an object to stay in a place, the net force should be equal to 0. for object to stay at a place, the net force should be equal to 0 Newton. Agree? 0 Newton. Now, what is happening over here? We have the object being pulled down by gravity, m into g, and there should be an upward force, Fb, right? They should be equal to each other. How can we tell that? See, we know that F net can also be given as mg minus Fb, but this value is 0, right? So Fb should be equal to, when I transpose this, is equal to mg. Means what? They should be equal to each other. The weight of the water displaced should be equal to the weight of the object, and that's what is happening over here. 30 gram, 30 gram. 0.3 Newton, 0.3 Newton. Is it not? Agree? Even this two actually is equal, 30 gram and 30 gram. Is it not? So here, what is happening? It's not so. The displaced water weight is not equal to that of the object's weight, so it sank. As simple as that. So what can we tell? When the object will float, if and when, right, the displaced water is equal to the weight of the object. If it's not equal, it will sink. You guys can ask a question, what if it's more? That is something you guys can think of. Okay guys. So, but this two you need to understand. When will an object float? When it's able to displace water or any fluid equals to its weight. As simple as that. You should be able to displace that much of water or fluid. Okay guys. So that is your conclusion. You can write the heading. And now you guys can write the conclusion and mathematical aspect. Mathematical reasoning. From the point of mathematics. Whatever you guys want to write the heading as, but yeah, you guys understood this math. Floating object. Yeah, done. Please copy this.